Hello everyone, Assalamu alaikum. Today I am going to discuss how we will calculate the genetic risk. Okay, so let us start. To identify a genetic risk, we have to know first that in our body we have 22 pair of autosome and one pair of sex chromosome, right? We all know that. So if it is a boy, this one pair will be X and Y. And if it is a girl, this one pair will be X and X, right? So this much we know. Now, come back to the autosome. So we have 22 pair of autosome. This 22 pair we got from our parents, both the parents. So 22 chromosome from the father plus 22 chromosome from the mother. So total 44 chromosome. These are called autosome. Now, in autosome, we have genes. Also in sex chromosome, genes are the basic unit of a chromosome. So we have genes that are specialized proteins. Okay. And in this chromosome, there is a specific location of the gene. This is called loci. Okay, there is a specific location. So in the picture, you can see there is a E and E. So these two genes are homologous. That means they are similar gene. Their strength is similar. Their expression is similar. But here in this D, you can see the pair of genes that are not same. Okay, one is capital D, another is small d. So among these two D, one gene will be affected, or you can say dominant, or you can say recessive. Okay, so one D that is abnormal, then the another D. So in this case, the any one of the parent that transmit the gene, okay, either he or she is a carrier or he or she is a sufferer. So here two genes are different. This is called heterozygous state. Okay. So by this structure, we can know that we have specific location for each pair of gene. This is called loci. And we have homologous gene and heterozygous gene. So now let us see how genetic risk calculation done. Before starting the risk calculation, we have to know this box very well. This is for the autosomal recessive trait. Okay. Now, relation to the person affected by the disorder. That means if any offspring is affected, like son or daughter is affected, then the chance of being a carrier to the parents is 100%. That means parents are 100% at risk of being a carrier if they have a sufferer boy or sufferer girl. This is only for autosomal recessive. Remember, this is not for autosomal dominant or not for X-linked dominant. This is only for autosomal recessive. Now, if any person has an affected sibling, like a affected brother or affected sister, that the chance of being a carrier of that sibling that is unaffected, this is unaffected, okay, unaffected sibling is 2/3. Okay, any person who is affected, chance of his or her aunt or uncle being a carrier is 1/2. That means this aunt or uncle has an affected niece or nephew. Similarly, chance of grandparents being a carrier is 1 by half. Chance of first cousin, okay, 1 by 4. If you have a cousin, first cousin, like your maternal son or daughter, or paternal son or daughter, okay, from your paternal side, from your father's brother or uncle's son and daughter, or your aunt's son and daughter, like this. So if they are affected by autosomal recessive disorder, then you can be a carrier. The chance is 1 by 4. Okay. Second cousin means next generation. So your cousin's son or daughter, if affected, then you can say you can be a carrier. The chance is 1 by 8. So this is the risk of carrier with an affected individual. Okay. Now let us see some case scenario by which we can identify how we calculate genetic risk. This question, see this question. A man who has a child with spinal muscular atrophy from a previous relationship, that means this man had another wife or girlfriend. From them, they have a child who is affected by spinal muscular atrophy. Now he married again with another woman. So he would like to know that his risk of having an affected child with his new unrelated partner who has no family history of any genetic disorder. That means his second wife or second girlfriend does not have SMA or no family history of any other genetic disease. He wants to know that my future child will be affected by SMA or not, because he has an affected child already. So here one information is given that population chance of SMA is 1 by 40. That means without any genetic background, without any problem in the family, any person, any normal person can be affected by SMA. The chance is 1 by 40. This is called population risk, population carrier risk. Okay, he can carry the gene without any family history. It is 1 by 40. Now, which of the following best represent their risk of having an affected child? So now let us see the calculation. So how we will calculate this condition? Okay, so we know, first of all, you have to know this disease is autosomal recessive, SMA. So it is an autosomal recessive condition. If we know that the both parents are carriers, then how many child will be affected? It will be 1/4. How this is 1/4? This we all know. 25% will be sufferer, 25% will be normal, and 50% will be carrier. So this is the equation of autosomal recessive disease, right? 25% they possesses the both bad genes, so they are affected. 25% will possess the both good genes, so they are unaffected, and also they are not a carrier. And 50% will carry bad gene either from father or from mother. This is for the autosomal recessive. So 25% means 1/4. So 1/4 1/4 sibling, 1/4 child will be affected if the parents are both carrier for autosomal recessive. Now this man is definitely a carrier because he has an affected SMA child, and his wife, previous wife, must be a carrier. Both are carriers. So if the man is in this question has an affected child, so he will be a carrier for SMA. So we know that he is a carrier. Definitely he is a carrier. And as his partner, new wife, that is the second girlfriend or second wife, she has no genetic background. So she has family history. She has population risk. Population risk is how much? We know population risk is 1 by 40 because he has no family history of genetic disease. Now, how you will calculate this thing? This is simple math, okay, simple mathematics. So, to calculate the risk of couple having an affected child, inherited two mutant allele and thus having affected gene. So, we have to assume that both the parents, new mom and the father, both the parents carrier state is how much? Okay, we will multiply them. So, multiply the chance that the father is a carrier, a mutant allele. So, father is a carrier, okay, because father has an affected child. So, how much chance, risk he will transmit the gene? This is 100%. We already know from the box that if any person has a affected child, okay, risk of transmission is 100% or 1. Risk of carrier state is 1. We already know from the previous box. So here the father's carrier state will be 1. Chance of carrier state is 1. So father has two gene. One is bad gene, another is good gene. So what is the chance that he will transmit bad gene? Definitely it is half chance, because we don't know father will transmit the bad gene or good gene. So 50% chance that the father will transmit the bad gene. Now the mother is unaffected. So mother has 1 by 40 population risk. Okay. So if the mother is a carrier of bad gene, that is 1 by 40. Okay, then chance is 50% that she will transmit bad gene to the child. This half and this half are similar. Why? Because we are assuming both the parents are carrier. Father's chance is 100% carrier, mother's chance is 1 by 40 carrier. If both the parents are carrier, then only the child will be sufferer, because it is autosomal recessive condition. Okay, so again, father's chance of being a carrier is 1, and chance is 50% that father will transmit this bad gene to the child. Mother's chance of being a carrier is 1 by 40. Again, chance is 1 by half or 50% that mother will transmit this bad gene to the child. So total risk will be 160 if you calculate 160 by 1. So this is how this autosomal recessive condition, where father is a carrier but mother is not a carrier, mother has only population risk. So we will calculate by this method the chance of being an affected child. Okay, here it will not be a daughter or son, because affected child can be daughter or can be son. We don't know, because it is autosomal recessive. Okay, now a healthy man who has a cystic fibrosis brother, that means a man whose brother is affected by cystic fibrosis and his partner is unrelated, tar mane they do not have any family history. Okay, they do not have any family history and they are not related with by family or by blood. Unrelated parent partner who has no family history of cystic fibrosis want to know their chance of having an affected child by cystic fibrosis, because here the man's brother is affected. So man is worried that my child will be cystic fibrosis or not. So how you will calculate this risk? And we know that cystic fibrosis is an autosomal recessive condition. This we all know. So let us see. So here the man's parent are obligate carrier. Why? Because they have a affected son. So the man's parent are obligate carrier for cystic fibrosis because it is autosomal recessive condition. Okay. Because he is unaffected, his chance of being a carrier is 2/3. We already know from the previous slide, first slide, that if any person is affected by autosomal recessive disease, chance of the sibling being a carrier is 2/3. So here the man has a brother of cystic fibrosis. So he can be a carrier of cystic fibrosis. The chance is 2/3. And his partner, that means his wife, is not a carrier because she doesn't have a family history. Okay. So population risk will be 1/25. So this is for wife and this is for the man and this is for the woman. Okay, so man's chance is 2/3 of being a carrier and female's chance is 1/25. This is the population risk. So how we will calculate now? So suppose they both are carrier. Man's chance is 2/3 and female chance is 1/25. Now suppose they both are carrier. They both are carrier. If they both are carrier, then what will be the chance of they are having an affected child? According to the formula, 25% children will be affected. So their chance of affected child is 1/4. So this is the formula: 2/3 for the man, 1/25 for the woman. Okay. So both of them, their calculation is 2/75. Okay. So 2/3 into 1/25 into 1/4. How much is the calculation? It will be, sorry, let me do again. It is 2/3 for the man, 1/25 for the woman, and both of them are carriers. So it is 1/4 for the child who will be affected by cystic fibrosis. So if we do this multiplication, it will be like 1/6 into 1/25. So if you calculate, it will be 1/150. Okay, so this is the simple math calculation. So this is how you can identify that a autosomal recessive condition, when brother or sister is affected, 1/150th chance that an unaffected brother or sister will have an affected child of cystic fibrosis. Now let us come to another question. A man's niece means brother's daughter, has a diagnosis of cystic fibrosis. So previously the scenario was brother affected. Now brother's daughter. That means it is first one generation after. Brother's daughter is affected. So he is the uncle. Okay, has been diagnosed with cystic fibrosis. There is no other family history in the family, including his 4 other siblings and their children. Now, if this man's wife is unrelated and she has no family history of cystic fibrosis and population risk is 1/25. So how you will calculate this relation? So here we have to calculate that this is a man who has an affected niece. Okay, niece. So his uncle, and his wife has a population chance. That means 1/25 chance, his wife. So let us calculate this thing now. See, the man's brother is an obligate carrier because man's brother has an affected child. So this man's brother is an obligate carrier. One of the man's parent must be a carrier. Okay, we know that if both the parent are carrier, then only they have a sufferer child. Here, this man's parent, one of the parent is a carrier. Okay, because his brother is not affected and 4 sibling is not affected. Okay, but his brother is a carrier, definitive carrier. Why? Because his brother has a son. His brother has a son who is affected by cystic fibrosis. So brother is called obligate carrier. Obligate means must. So brother is obligate carrier, but one of their parent, this brother and this man, one of the man's parent, they are carrier. Okay. Now, according to the formula, if any person has a affected first cousin or affected child, brother's child or sister's child, okay, or he or she is an uncle or aunt, then chance of being a carrier, I'm the aunt or I'm the uncle, chance of being a carrier is 1/2. If I have a affected niece or nephew, okay, the chance is 1/2. This is from the genetic risk calculation, we know. So the chance of this man being a carrier is 1/2, and his partner's chance is 1/25, because partner is unaffected and partner has a population risk. And if these both are carrier, then they have an affected child, the chance is 1/4. So how much will be calculated? How much this will be calculated? Okay. So this will be 1/200. 1/200. Okay. This is how we did. We did by assuming that both the parents are carriers. And what is the chance of the man? This man's chance is half, because he has an affected niece. And this woman's chance is 1/25, because she doesn't have a family history. And when both have a chance of being a carrier, then only they have a affected child, and it will be 1/4. Every 4 children, he can have 1 children, that is a sufferer child from cystic fibrosis. Okay, this is only for autosomal recessive condition. In autosomal dominant condition, calculation risk is not like that. Now the next question is, a couple came to you, they both have a achondroplasia. This couple is diagnosed with achondroplasia. Now they want to know that if they take a child, what is the chance that the child will be normal? Now we know achondroplasia is autosomal dominant. This we know, achondroplasia is autosomal dominant condition. So according to the formula, these parents, both the parents have a bad gene, because they both are sufferers. So both the parents had bad gene. This is good gene and this is bad gene. This is good gene and this is bad gene. So according to this autosomal dominant disease, this man and his wife, they both have a bad gene. Now, if both the person has bad gene, what will happen? See here the genetic chart. Here both the parents are affected. Suppose both the parents are affected. So this man has a bad gene. This is the bad gene. And this woman has a bad gene. This is the bad gene. We know in our each chromosome we have 2 genes. One is here, one is one good gene and one bad gene. So if you do this thing, that if you multiply this, how you will multiply this? How you will draw this picture? Let me show you how I will draw this picture. Here, this is the man and this is the woman. Man has a bad gene because he has achondroplasia, and female also has a bad gene because female is also have a achondroplasia. So if this gene and this gene meet, then the child will have severe achondroplasia. And if this gene meet with this gene, and if this gene meet with this gene, okay, I'm drawing the picture again. So this is the man and this is the woman. He has a bad gene and a good gene, and this woman has a bad gene and good gene. So if this gene and this gene meet, he will have severe achondroplasia. But if this gene meet with this gene, then what happens? He will also have achondroplasia, because one gene is enough. It is a dominant condition. One gene is enough. Now, if this good gene mix with this bad gene, also he will be affected. But if this good gene mix with this good gene, this is good, okay, good gene. So what will happen? This will be unaffected. So good gene and good gene, if these two good gene meet, he will have an unaffected child. So we have to remember that in autosomal dominant condition, 25% chance that the child will be severely affected by achondroplasia. 50% they will be affected by achondroplasia, and 25% chance they will be unaffected. So this 25% means 1 by 4 chance that this couple who both have achondroplasia, they will not transmit the bad gene to the next offspring. Okay. Now, let us come to our another picture. So this is the answer of this question, that achondroplasia is an autosomal dominant condition, and as such, a single allele is sufficient to cause the disease. If both the parents are affected, that means both the gene are affected, it is called homozygous state. And in homozygous state, okay, one child will be sufferer for severely affected disease. Okay, so 1 by 4 chance that they have a severely affected disease. This is best understood by looking at the Mendelian inheritance chart we already showed to you. It is also important to remember that 80% cases of achondroplasia occur due to a new mutation. That means they do not have a family history, new mutation. Okay, so in this picture we showed you that, here we showed you that if the both parents are affected in achondroplasia, one child will be severely affected. Okay, then two child will be only affected and one child will be unaffected. This is one child means 1 by 4. This is 1 by half chance, and this is 1 by 4 chance. Okay, so this is the inheritance of autosomal dominant condition. If both the parents are affected, then 1/4 chance that they will have a normal child. Okay, now next question is, this is the last question, that the normal sister of a boy with Tay-Sachs disease has asked for her risk of being a carrier state. So we know autosomal recessive, Tay-Sachs is a autosomal recessive condition. And if any person has an affected brother or sister of Tay-Sachs disease, then the chance of being a carrier is 2/3. Okay, so this sister who has a brother of Tay-Sachs disease, she is asking that, what is my chance of being a carrier? We already know this is 2/3. How this 2/3 is calculated? So Tay-Sachs is an autosomal recessive condition. To have an affected brother, both the parents must be a carrier. So this daughter, this sister and this brother, they have a parent, and their parent is obligate carrier, because if both the parents are not carrier, then how this boy is sufferer? So definitely they have a carrier parents, and both the parents are carrier. So in each pregnancy, her parents have 1 by 4 chance of having an affected. So we know from autosomal recessive, 1 by 4 chance he will be good, no disease. Okay, 1 by half chance, 50% chance she will be a carrier, and 1 by 4 chance she will be a sufferer. So here, in this question, the sister is not a sufferer. Sister is normal. It is given that sister is normal. So we can discard this 1 by 4 chance. Okay, we can discard 1 by 4 chance of being unaffected. So we will take 2 by 3 chance. it is 66%. Okay, so as the sister is normal, so we can discard this 1/4 chance. Okay, given that the sister of the affected boy is unaffected, the first possibility can be eliminated given a 2/3, 66% chance that she is a carrier. Okay, so as she is unaffected, we can discard the affected portion, 1/4 portion. This is affected portion. We can discard this one. Okay, then how much is remain? 1/2 plus 1/4. This much is remain. So if you take 4, then it will be 2 plus 1. Okay, so the chance is here not 1/4. Here we will discard total 1 portion. Total 1 portion we will discard. We will divide the child in 3 portion. Okay, 1 portion for carrier, another portion for carrier, and another portion for normal person. Okay, so chance of being a carrier we will divide by 2/3, because we discard the affected portion. 1/4 we discard. Okay, so this is how we calculate the genetic risk of autosomal recessive condition when a brother or sister is affected. Okay, now I hope this video was helpful for you. So if you remember this genetic structure, and if you remember this genetic risk calculation, how I will calculate the risk in case of autosomal recessive condition, then you can remember the rest of the equation. Okay, because population risk will be given in the paper, because population risk is different in different disease. It is not same. So population risk will be given, and how you will calculate by seeing this chart, the affected person and the risk of the unaffected person. Okay, then it will be easy for you. Okay, so I hope this is helpful for you. Thank you very much, and I will show some other basic structure, basic genetics in my next videos. Okay, thank you very much. And to get the update, you can subscribe my channel, so that whenever I upload any video, you can get notification. Okay, thank you.